Alrighty, guys. So let us get into this whole graphs sort of recap, consolidation, revision, make sure that we're happy. Now, what we have been talking about is very much this concept and this idea of relationships. And I've said many times that one of, or rather two of the most important ways for us to describe or work with relationships is through formulas and through graphs. And these are going to become more and more important as you move up in maths. Graphs or functions is going to be a very, very important section that you need to be comfortable with. And so being able to just understand these basics and understand these relationships is very important. All right, so the first thing that we need to be comfortable with doing, sorry, I think my camera's a bit dirty, is we need to be comfortable coming up with formulas according to a specific relationship, and then using those formulas to draw graphs or to find inputs or find outputs, etc., etc. So just a little reminder, we've got two important values that we need to work with. One is your output value, and basically that is the answer you get once you've performed some sort of operation that is expressed with Y. And we've got our input value, which is basically the number that we perform operations to, and that is represented by X. Alrighty, so I don't know, chaos. So what we need to be mindful of is that we are going to be working with X's and Y's when we talk about graphs. There is like specific notation or specific symbols that we use in graphs, but that will sort of come up later on. So X and Y, very important. Now, I've said before, and I'm going to say it again, you can almost think of it or a relationship like a number machine of you taking X, putting it in, doing a whole bunch of operations, and then getting an answer, which is your Y. So if we have a look at this first example, it's saying to calculate the output number, 7 is subtracted from the input number, and that answer is multiplied by 5. So basically it's saying to me to get Y, because remember this output is Y. If I want to get Y, I need to take my input, which is X, I need to subtract 7, and then I need to multiply it by 5. So we can come up with an equation that expresses this. We then can say that Y is equal to my input number minus 7, and that whole answer is then multiplied by 5. Now, you don't have to put the 5 at the beginning. You can definitely write it as Y is equal to X minus 7 times 5, or you can even use a multiplication sign. What is very important here, though, the fact that you are saying X minus 7, that whole expression, so in brackets, is being multiplied by 5, because it said very specifically to me that the answer you got when you said X minus 7 is multiplied by 5. So we need to have those brackets there so that we are showing that it is the answer of the subtraction in order to get that value. Right, so let's have a look at the second one here. I'm going to read it out, and then hopefully someone can raise a hand or you can pop it in the chat what the equation would be. So to calculate the output number, 7 is, oh no, there's more. 7 is subtracted from the input number. That answer is multiplied by 5, and 3 is then added to this answer. So this looks very similar to the first one we've just done, but now we've got a 3 being added to the answer. So I'll give you a second to think about it. If you want to raise a hand or you want to pop it in the chat, you can put your answer there, and we'll see what expression or rather equation we get. Right, I do see the question about top achievers. What I will do is when we take a brain break, I'll quickly go back up there so that we can see. I'm so sorry, I got so distracted and I just jumped into the lesson.
You posted them though. I know there was like 3 ends. Yeah.
I did, and then I didn't say anything about it. I just got distracted. Okay, Wangi, do you want to try for us? What would the equation look like?
Hi, ma'am.
Hi.
I'm not really I'm not really sure about my answer because I'm used to these in Afrikaans, but I'm just gonna give it a try.
Yes,
Okay,
that's
so
what I like to hear.
I said 5 and then bracket x minus 7, and then I closed the bracket and I said plus 3.
Excellent. Well done. And that should be equal to y.
Thank you.
Well done, Wangi. Okay, guys, so this is exactly it. We know that the output number, which is y, to get, I'm going to start my sentence again because that was bad. To get our output number, we need to subtract 7 from my input number, which is what is happening in this bracket. We need to times that answer by 5, which is why we've got a 5 in front of the bracket, because remember, there is a times between the 5 and the bracket. And then we want to add 3 to whatever that answer is. So there is my addition of 3. Now you can, if you wanted to, go and distribute the 5 into the bracket and simplify. So if you wrote your answer as, or if you distributed and got an answer of 5x minus 35, and you went and simplified this equation, your answer could definitely be 5x minus 32. That is exactly the same thing. All we've done here is we have gone and taken the coefficients. Oh golly, this is just chaotic. Sorry, my screen's just doing weird things. All I've done is I've multiplied the 5 to the x to get 5x, and I've multiplied the 5 with the negative 7 to get a negative 35. And then I saw that negative 35 and positive 3 are like terms. And so when I say minus 35 plus 3, I get a negative 32. And so you're definitely more than welcome to simplify. You are definitely more than welcome to leave it unsimplified, just because that does actually describe the expression that we gave, but both mean exactly the same thing. Nongile, do you have a question?
Yes, ma'am.
Yes.
Ma'am, you are a little too fast for me. So can you please repeat again from 5 brackets? That's how did you get 35?
This one over here? Oh,
yes,
how did I get 35? Okay, cool. So guys, I'm just going to take these scribbles off and start again, because there is a lot going on here. So Wangi had given us an equation of y is equal to 5 times x minus 7 plus 3. Because there is the 7 subtracted. The answer is multiplied by 5. So that's why we've got a 5 there. And then it says 3 is added to that answer. So that's our expression. Now you can leave it like that, but as Longile said, I can also simplify it. So if I want to simplify this expression, I can. I would multiply the 5 into the brackets to both the x and the negative 7. And remember, if you need to, just do these multiplications on the side for yourself so that you don't get too confused. But if we go and multiply 5 times x, I get 5x. So I currently have y is equal to 5x. If I take 5 times a negative 7, a positive times a negative is a negative, and 5 times 7 is then negative 35 plus 3, and negative 35 and positive 3 are like terms. So if we go and use a calculator, or if we go and add 3 to negative 35, we're going to get 5x minus 32. And this expression in red and this expression in blue is exactly the same thing. The red one is simplified, whereas the blue one is not. But they mean, I can't spell simplified, is simplified. The blue one is not simplified, but they mean exactly the same things. Now, if you are going to, multiply the coefficient in, you do need to check for like terms, and you do need to make sure you've added all your like terms together. Otherwise, you just leave it as it is, unsimplified. Alrighty, so do take a screenshot before we move on. And then we're going to have a look at some other ways that we express these relationships. Now, guys, what's really important to see, just while you're taking a screenshot, is that all of these concepts link so much with other sections that we've done. So, I mean, this that we've just spoken about here is talking about algebraic expressions. We're talking about equations. And so it's very, very important that we do become comfortable with, like maths in general, so that we can be comfortable doing these things. Right, Tando, I see your hand before I move on. Do you have a question? Okay, I'm going to move on then. Whoops. Alrighty. So remember, I've also said to you that one of the very useful ways to start drawing graphs is to be able to draw a table. So if you are ever confused about wanting to draw a graph, you can draw a table, and that will pretty much give you a set of coordinates that you can go and draw. Okay, Tando, I'm going to try again.
Ma'am.
Hi.
So my question, it's on question B. So I wanted to find out, so I have two versions of what I wrote.
Okay.
So the first one is the very same one as the one you wrote.
Perfect.
Then my other one, it's y equals brackets x minus 7 brackets 5 plus 3. So I wanted to find out if both of them are correct, or is the first one correct?
Both of them are absolutely fine.
Okay, ma'am.
Yeah. So the first one is the one like we generally write it as. We generally try and put the number in front of the bracket, but both say exactly the same thing. So either one is absolutely fine.
Okay.
All right. Cool. Well done. Okay, guys, so let's have a look at these tables here for ourselves. Oh, gosh. It's all going mad. And so what we're doing here is we're combining two methods of representing relationships that we know. Now, I would not stress about flow diagrams. They are not something that you need to study super hard, but they are an important part of understanding relationships, because this is like my number machine. I'm taking my input, maybe. I'm doing all of the operations that the flow diagram tells me to do, and I'm getting my answer, which is my y. So here in your table, you've got an input and an output. And if we apply the rule, we should get the correct answer. And this will then allow me to draw a graph. So if we have a look here, I'm going to do the first one with you, and then I'll get people to answer the rest. If we look at our first one, we have got an input of 5. So what that's saying is that I'm putting 5 into this flow diagram. So the first thing I need to do, and let's do our working out up here, is I need to take 5 and I need to times it by 2. So that's the first block over there. We know that 5 times 2 is 10. I'll then take that answer and put it into the second block, where I now say 10 plus 3, which we know is 13. And then taking that answer, I need to multiply 13 times 5. Now, if you are very good at your 5/13 times tables, hopefully that's not too bad, but otherwise grab your calculator. And 13 times 5 is 75. And so this final answer that I get is now my output value that I can go and write down for my specific input. Alrighty. So again, all we're doing here is we are taking the input that I give you. Your guys, not 75, 65. Maths today. Thank you. I'm assuming those were some of the hands. And thank you everyone on the chat. Who knows? My brain's just gone to mush. Can't remember what I was saying. So again, we take our input, we perform the operations that we need to do. So to remind you, this times 2 we did in our first step, because that's what it told me to do. I then did the plus 3 in my second step. And each time I'm taking the answer and applying it, and then I'm timesing by 5. And so by doing these operations, I'm getting my corresponding output. Alrighty, so let's see who can give me an answer for an input of 10. So I'm taking 10, I'm timesing it by 2, I'm adding 3, and then I'm timesing it by 5. So make sure that you are doing the operations according to your flow diagram. I'm going to give everyone a second. I do see lots of hands, but I'm going to give everyone a chance to just give it a go. Right, Lufuno, do you want to tell us what is the answer?
Yes, ma'am. The answer is 115, ma'am.
Excellent. Well done. 115. So guys, 10 times 2 is 20. 20 plus 3 is 23. And 23 times 5 is exactly 115. Okay, I'm going to pick another hand that's still up. If you get picked and you don't want to answer, you can say so. Oh, lots of hands. Wonderful. Fareed, would you like to give us the output when our input is 15?
Yes, yes. 15 times 2 equals 30.
Yeah.
30 plus 3 is 33.
Good.
5 is 180.
Try the multiplication again. What's 33 times 5?
165, man.
Good,
Sorry.
well done. Excellent. Okay, so guys, again, 15 times 2 is 30. 30 plus 3 is 33. And 33 times 5 is indeed 165. Well done. Okay. Sihle, would you like to give us the output when our input is 20?
Yes, ma'am.
Yes.
20 times 2 is 40. 40 plus 3 is 43. And 43 times 5 is 215.
Excellent. Well done. I don't even have to repeat anything there. Sihle gave it all to us. So 215. Nafikas, would you like to give us the output when our input is 25?
Hi, ma'am.
Hi.
The output for 25 is 265.
Excellent. Well done. So 25 times 2 is 50. 50 plus 3 is 53. And 53 times 5, 265. Now, guys, this is again why having a calculator is quite useful. Sometimes these multiplications can get quite big, and just being able to quickly do it on a calculator is very helpful to us. Alrighty. Please, just a reminder to mute yourself once you have answered the question. Otherwise, it becomes a little bit chaotic.
Yes, please, because then I can't find you, because the lower your hand down, then I cannot find you anymore.
Okay, and Tombi, would you like to give us the last one? Don't worry, guys, there's lots more.
Yes, ma'am. So you say 30 times 2 gives you 60, and then 60 plus 3 is 63, and then 63 times 5 it gives you 315.
Excellent, well done.
Thank you, ma'am.
Okay, guys, so what we're seeing here is that as my X values, so as my input values are getting bigger and bigger and bigger, so are my output values. And so again, we could potentially go and draw a graph for this to show that it's increasing at this rate. Alrighty, I'm just skipping some because I want to do this one rather. Let's have a look at question C, and then we're going to take a little break. So don't worry, we're going to do a break. But let's have a look at C first. So C, we've got plus 5 divided by 2 minus 1. So we'll do the first one together. If I take my input, which is X, remember, to get my output, the first thing I'm going to do, I don't even know where to do this, let's go here, is say my input of -3 plus 5, which we know gives us positive 2. So that's my first block done. I then need to take 2 and divide it by 2 according to my second block, which we know gives me 1. And I then need to take my answer and subtract 1. So 1 minus 1, which we know gives us 0. So we need to do the same thing with all of these other inputs here in order to get our output. I'm going to give everyone a second, a chance to give it a try. I do already see quite a few hands, but let's give everyone a chance, and then I'm going to ask for some answers. So add 5, divide by 2, and minus 1. All right, Carly, would you like to give us the next one?
I think it's going to be 0 is because that
Okay, so we're doing the input of negative 1. Carly, are you still there? Okay, I feel like we might be having a bit of a sound issue, so I can come back to you, Carly, don't stress. And Paul, would you like to give us the output for negative 1?
It will be 1.
Excellent. Do you want to walk us through the steps?
Yes, because I add negative 1 plus 5, which gives me 4.
Good.
And then 4 divided by 2, which is equals to 2.
Yeah.
Then 2 minus 1, which is equals to 1.
Excellent. Well done. Fantastic.
Thank you very much, ma'am.
Okay, guys, so there we go. Our Kiwi, would you like to give us the next one?
Ma'am, the answer is 1,5.
Okay, do you want to walk us through it?
Okay, so 0 plus 5 is equal to 5.
Good.
Then 5 divided by 2 is equal to 2,5.
Yes.
Then 2,5 minus 1 is equal to 1,5.
Excellent. Well done. So guys, sometimes we do get decimals or sometimes we do get fractions. Now you can either write that as 1.5, 3/2, or you can write it as a mixed number 1.5. It really doesn't matter. It's completely up to you. I always prefer an improper fraction, but that's just my personal preference. Okay. But any of those 3 forms would be absolutely fine. No problems there. Leoborna, do you want to give us the next one?
Yes, ma'am.
Okay.
The answer before, ma'am.
Okay, walk us through it.
Wait. I added 5 to 5, and then I got 10.
Good.
Then I divided 10 by 2. Then I got 5, and then I minused it by 1.
Giving you 4. Whoops.
Yes, ma'am.
Excellent. Well done, Leoborna.
Thank you, ma'am.
Guys, you're on it tonight. All righty. Oh, sorry.
We're applying my peps. Well done.
I want to say Andre. Do you want to give us the last one? Am I right?
Hello?
Am I right? Andre?
Yes, hello.
Okay. Yes. Tell us the last one.
Okay, so I said 13. 13 plus 5. Hold up. 13 plus 5, which gave me 18.
Good.
And I divided it by 2, which gave me 9.
Good.
And I minused it by 1, which gave me 8.
Fantastic. So there we've got our output of 8. right? And again, guys, what we see is that as my X values are getting bigger, so it's going from a -3 to a +13, my Y values are also getting bigger. And so again, we could draw a graph so that we can see this relationship. Now you can still draw a graph if there is a fraction. And maybe what we'll do, we'll take a break and we'll come and try and draw this graph. But you can still draw a graph when there are fractions, because if we think about this on our y-axis, okay, it's going to be a very weird looking graph, but it's all right. If we want 1.5, we know that 1.5 is halfway between 1 and 2. And so I would plot my point halfway between the two. That's fine. We can plot decimals. That's not a problem. So having fractions or having decimals doesn't change our ability to draw a graph. It just means that we need to be mindful of where we actually go and plot that point. Alrighty, so take your screenshots, please. There's quite a few hands up. So please, if you have a question, obviously do leave your hand up, but if you don't have a question, please lower your hand. There will be more opportunities for you to give answers. Please don't worry. So please lower your hand if you don't have a question. Right, so Kagiso, Lorraine, Carly, Lungile, I still see hands up. I'm assuming these are all questions. Okay, Lungile, what is your question?
Hi, ma'am.
Hi.
My question is that how do you change, why do you change the numbers? Just like, where do you get -3 plus 5 and 2 divided by 2? Why don't you use -3 all the numbers?
Okay, so we don't use -3 all the time because as I start to perform operations, the value that I'm working with changes. So the second I add 5 to -3, I'm no longer working with -3, I'm now working with a 2. And so I need to take my answer from each step and move it to the next step because that is continuing the operation that I'm working with.
Okay, thank you.
Okay, good. Alrighty, Carly, do you have a question for us?
Excuse me, Miss, when we're going to do Pythagoras and dot ending, it's because that next week and Friday, we're starting with a maths paper and I struggle with dot handling.
Okay, so as Yolanda said on the chat, all of those videos should be on Watobe's website. We will be starting with Pythagoras next week. So that's when, but otherwise you are welcome to ask questions via the WhatsApp line or join our lessons early and ask questions.
Thank you, ma'am.
Cool. Alrighty, guys, so let's have a look at our brain break here. So again, brain break, if you're new, basically we're just taking a little break from what we're doing. You can get up, stretch. If you need to run to the loo, you can run to the loo quickly. But I always put up a little brain teaser. So here today, it looks a little bit different because we have to work both, you're my words, have to work both horizontally and vertically in order to get these numbers down the bottom and along the side. Now, I'm going to give everyone a chance to have a go. When you have an answer, please do put it in the chat. And then the first person to get it right, we're going to get to hopefully explain it to us. Right, and there's my math joke for the day. But have a go. I already see some hands, which is awesome.
We are back at it, my peeps. We can do this.
Okay, so like I say, put your answers on the chat so that we can see the first person to get it right and then hopefully get an answer. I do see the hands. We're just going to give everyone a chance.
We can do this, my babes. I feel like maybe I should just work it out because I also don't know what the answer is. We got it. Let's go, my pep. I'm cheating. Gisem is giving me answers.
I mean, teacher Sam's hoping that she can do maths today because last week it wasn't going so well. I do not make these jokes myself, guys. I'm not that funny, unfortunately. I wish I was. I wish I had that skill, but unfortunately not.
My peps, let's not deviate, eh? Try and work it out. It's good for your brain. Try and find an answer, a final answer, my peps.
And guys, remember, do the operations in the correct order. We need to remember what comes first.
Yeah. Let's go, my peps. We can do this. So far, we haven't seen the correct answer. If you have the right answer, put it on the chat, and then we can see it.
I see Junior helping us out here. If you're feeling stuck, start with this column over here. So ask yourself, if you have to take 2 pairs of pants and times it by 10 and get 200, what should the 2 pairs of pants be worth? And look at the operations that we want. Okay, I'm going to give everyone another minute or so, and then I'm going to ask some people with hands up, and we'll see how we go.
Let's go. We want to see who's going to get it right first. Let's do this, my peps.
Alrighty. Right, I'm not seeing any answers, so let's see. Maybe I can't do maths today. Lorraine, do you want to help us out?
Hi, ma'am.
Hi.
Madam, for that one that you have tackled,
Yeah.
I said 200 divided by 10,
Yeah.
and it gave me 20.
Good. So 2 pairs of pants are worth 20.
Yes.
Excellent. Do you want to keep going?
Yes.
Okay.
For the one on top,
Yeah.
I said 160 divided by 20.
Good.
And it gave me 8.
Excellent. So 2 roast chickens are 8.
Yes. Thank you, ma'am.
Okay. Is that okay? Do you want to give us the cookies? Over here.
Madam, that's an easy one.
Okay. So what is it?
36 minus 8,
Yeah, which is
28.
excellent. Well done. Okay, so guys, now we've got the values of all of these things. So Lorraine, what is one pair of pants worth? If 2 is
10.
20. Good, well done. So we've got 10 plus, it's the same amount of cookies, so 28. And then Lorraine, one chicken is then worth?
8.
2 is worth 8. So what's 1 worth?
4.
Good, well done. So guys, what we need to remember is that we first need to do the multiplication of 28 times 4, which gives us 112. And then it's 112 plus 10, which is 122. Thank you, Lorraine. Well done. Alrighty, so that is essentially how we do these brain breaks. This is not something you need to stress about. It's just something fun to try and give your brain a bit of exercise outside of just the maths that we do. So if you want to take a screenshot, by all means, I do still see a hand, 539403334. Just remind me of your name, and then you are welcome to ask your question.
Hi, ma'am.
Hi.
My name is Sikuye. So, ma'am, I have a question. So, since I see it's written that 2 roasted chicken amounts to 8, how come it amounts to 8 and not to 16? How do you know that it amounts to 8? Because
Okay,
I said it was 16 because I divided 36 by 2 because there are 2 pictures.
Okay, so we got the roast chicken because we worked with this row over here. So we said 160 divided by 20 will give me the 8 that I need to times by. So if you know.
Oh, okay, yeah, thank you. I understand now.
Good. Alrighty. So there was the question about top achievers. There we go. I'll quickly go up. Sure. Okay, there we are.
Well done, well done, well done. You guys deserve a round of applause. Well done. Smashed it.
And guys, just a reminder, when you do your quiz, please try and log in with your name, because there were a couple 100%ers on the first try, but you were guessed. So I had no idea who you are, unfortunately. So please do try and remember to use your name when you actually do your quiz. Alrighty. So there we are. Whoops. Chaos. Right, so let's have a look at how we actually draw these graphs, because this is really where the fun stuff comes in. So we've got an input value that is multiplied by 3, and then 1 is added. So if we write a rule for ourselves, we've got y is equal to our input value, which is x, multiplied by 3, and then we're adding 1 to that product. So our rule would be y is equal to 3x plus 1. Now, what we can now do is we can get some input numbers for ourselves in order to work out the outputs. Now, what's really important, guys, is that you can pick any input numbers, whatever you want. As long as you apply the rule, it doesn't matter what your inputs are. Obviously, if your goal is to draw a graph, don't pick input numbers of 100, because then you have to have an axis that goes all the way up to 100. So don't pick too crazy a number, but you can pick any input number. So I'm going to pick some input numbers here for us. I'm going to go -2, -1, 0, 1, 2. And I want you guys to basically take these just like we were doing earlier, and I want you to go and work out what the output numbers are. So I'm going to give everyone a chance. Remember, what we do is we take our input. So we're going to do 5 separate calculations, and we substitute it into our rule in order to get our output. So give it a try. If and when you're ready to raise a hand or put it in the chat, please do. But I want those outputs there. So 5 output numbers is what I'm looking for from you. Can't speak. I'm just setting up my axis. As soon as I am done, I'm going to take some hands because I see that there are a couple already, which is awesome. Guys, remember when you do set up a set of axes, we have an X, which is the horizontal, a Y, which is the vertical, and we do need to label them so that we know which is which. It is very important. All right. Bocello, would you like to give us the first one?
Yes, ma'am. The first one is -5.
Perfect, -5. I'm going to do the first one just through substitution so that you can all see what's happening. So y is equal to 3 times -2 plus 1. We know that 3 times -2 is -6 plus 1. And so we've got y is equal to a -5. So that is my first output value. Fantastic, well done. Kagiso, would you like to give us the next one? There should be a little pop-up asking you to unmute.
That's one, I think it's -2.
Perfect, -2. So 3 times -1 is -3, plus 1 is exactly -2. Well done, Kagiso. Righty. Okay, your username says NF. I'm assuming there's a name attached to that. You can just let me know, but would you like to give us a third one? Oh, golly, sorry.
Ma'am, your answer, my name is Neelan, ma'am. Just
Yes,
call
sorry?
me that. And the answer is going to be 1, ma'am. Because 3 times 0 is 0 plus 1 is 1.
Perfect. What did you say your name was?
Just call me Neelan, ma'am. It's my name.
Okay, thank you. Right, perfect,
Pleasure.
guys, exactly. Remember 3 times 0 or 0 times anything is 0. And so we then have 0 plus 1. Right, Lesejo, would you like to give us the fourth one?
Yes, ma'am.
Okay.
Come. Ma'am, you're gonna say 3 brackets brackets 1
Yeah.
plus 1.
Yeah.
And this is 4, ma'am. Yes, ma'am, it's 4.
Excellent.
Plus
Well done.
4, ma'am, it's 3, ma'am, because 3 times 1.
Plus 1
Yes,
is 4. Well done. So exactly as Lesejo said, 3 times 1 is 3, plus 1 is 4. So we get our 4. Namkla, would you like to give us the last one? Oh, okay. We have Karabo, would you like to give us the last one?
Ma'am, 3 times 2 is 3 times 2 is 6 plus 1, which is 7.
Perfect.
7.
Good. Well done. Okay, guys, so those are our inputs and outputs. So remember, what this is doing is that this is now, this is now, please can we remember to mute ourselves?
Guys, please mute yourself, especially if your hand is not up. I cannot find you.
Yeah. So this gives us a pair. It is an X and a Y pair, and we know that that is a coordinate. And so what we can now do is we can now go and plot those coordinates. So just to help us, I'm going to write the coordinate pairs. So we've got a -2, -5, a -1, -2, whoops, 0, 1, 1, 4, and 2, 7. Now we have spoken about the Cartesian plane, and if you weren't with us, that's okay. The videos are online. But we know that we can go and plot these points. So remember, it's always X first and then Y. So we go to -2 on the X axis, down to -5, and we plot our first point. You do not need to label these points. I'm just going to write it in so that you can see which point is which. And we keep doing this with our points. So -1, -2, I plot my little point. I then have a 0, which is now on the axis, up to 1. So 0, 1, 1, 4, and finally 2, 7. And of course, I haven't given myself enough space. 6, 7, which would be here if I extended my line. 7, and I've plotted my points. And now what we see is if I sort of like think about the trend that I'm seeing here, I can see that I can join all of these points with a straight line, and I have got my graph. And what we see is that as these X values were getting bigger and bigger, the Y values were also getting bigger and bigger. And so what we have here is an increasing relationship. As my inputs get bigger, so do my outputs. And this is now the use of graphs, or the sort of functionality of graphs. It visually shows me this increasing relationship. Okay. So do take a screenshot if you need. Elena, I'm happy if we want to post the quiz link.
Okay, already.
Just 100, I see your question. You don't have to write the coordinates next to the point. I'm just writing them so that you can see which point is which. You don't need to. You only write down the coordinates if it says label your coordinates. Otherwise, you just draw the little circles. That's fine.